These days, the arrival of interstellar visitors within our solar system no longer shocks astronomers. They have come to expect such objects passing through from time to time. Yet every new guest still leaves behind a trail of unanswered questions. Just a few years after the first confirmed detection, it became clear that interstellar space is densely populated with debris ejected from distant planetary systems. The latest addition to this list is 3I/ATLS, and despite the growing routine of such discoveries, this one sparked an unusual level of excitement, far beyond what its brightness or size would normally warrant. The reason lies not only in its physical properties, but also in the whirlwind of speculation, rumors, and internet theories that quickly swirled around it. NASA's careful, measured explanations only added fuel to the fire. 3I/ATLS proved far more resilient than typical comets, and displayed spectral features rarely, if ever, seen in bodies born within our own solar system. Initially, interest seemed destined to grow slowly, as it usually does with newly discovered celestial objects. But everything changed when news outlets reported its supposed disintegration. It soon turned out they'd confused it with another comet, C/2025 K1 ATLS, which happened to share part of its name due to the same discovery survey. That comet, not 3I/ATLS, broke apart in mid-November 2025 into several large fragments, surrounded by what high-resolution images revealed to be a dust storm of countless smaller pieces. This event capped off a strange comet apocalypse. Just weeks earlier, the bright C/2025 R2 Swan vanished, followed shortly by the new Borisov comet C/2025 V1. Against this backdrop of cosmic fragility, 3I/ATLS's unwavering stability seemed almost uncanny. Right now, the object is about 300 million kilometers from Earth and still getting closer, not because it's heading straight for us, but because Earth's orbital motion is currently carrying us directly toward the patch of sky where it resides. Meanwhile, 3I/ATLS itself is moving nearly perpendicular to the plane of the solar system, and has in effect already exited the inner solar system. Yet due to orbital geometry, the two bodies are temporarily drawing nearer. Their closest approach, roughly 269 million kilometers, is expected on December 19th. After that, their paths will begin to diverge. Estimates of this encounter have been revised several times due to significant non-gravitational acceleration, likely caused by outgassing. Still, all models agree the object won't come closer than 200 million kilometers, and if it ever did, that would indeed be cause for serious concern. Why? Because data show that 3I/ATLS didn't just survive its close pass by the Sun, it withstood direct bombardment by solar plasma under conditions that shattered other comets into dust. Its durability is extraordinary. This resilience has fueled public speculation about a metallic spacecraft or an alien artifact. Scientists, of course, remain firmly grounded. Everything observed so far can be explained by natural, though unusual, processes. Still, the possibility of an atypical composition is quietly discussed, just not in official statements. On November 17th, a major coronal mass ejection erupted from the Sun, and by month's end, that plasma wave was expected to reach 3I/ATLS. Such events are a goldmine for radio astronomers. They reveal how an object reacts to a flood of charged particles. Does it heat up, outgas, emit unexpected radio signatures? It was during this tense period that NASA finally released an image of the object, captured back on October 2nd by the HiRISE camera aboard the Mars Reconnaissance Orbiter. The release was delayed by over a month and ultimately underwhelming. Just a faint, featureless smudge. No towers, no antennas, no geometric shapes. Only confirmation that the object remains intact. Accompanying the image were fresh spectroscopic data from Hubble and the James Webb Space Telescope. The results showed a chemical makeup rarely seen in native solar system comets, further strengthening the case for an interstellar origin. Non-gravitational acceleration was also confirmed, but that's common among active comets. What makes 3I/ATLS unique is the combination of all these traits. At the press briefing, NASA stressed there is zero evidence of artificial origin. Yet the tone of the event felt less like a triumphant announcement and more like an attempt to calm rising public speculation. Now the focus has shifted to radio emissions. Most comets are nearly silent in radio, but 3I/ATLS emits a weak yet steady signal dominated by carbon dioxide. This suggests its volatile ices are buried beneath a protective crust, and that crust appears unusually dense, possibly very dense indeed. The idea of a metallic core is not new, but in 3I/ATLS's case, it sounds more plausible than ever. Still, scientists caution, highly reflective ice can mimic metal, certain minerals conduct electricity well, and unusual thermal behavior could simply result from a porous but robust internal structure. To draw solid conclusions, we need more data: polarization measurements, phase curves, infrared and X-ray spectra. So far, the evidence remains sparse. Radar observations, which could definitively identify a metallic surface, are impossible at this distance. NASA also notes that the object's trajectory perfectly matches natural motion driven by gravity and outgassing. No signs of controlled maneuvers or artificial thrust. And critically, no narrowband radio signals, often considered potential technosignatures, have been detected. So, despite the temptation, the metallic object hypothesis remains just that, a hypothesis among many. Every oddity has a natural alternative. Only if multiple anomalies aligned, unusual reflectivity, slow thermal response, and strong radar echo, would the case for something truly exotic become compelling. In other words, a genuine metallic object in space would sing with a distinct voice. And if one day we hear that voice and realize it's not just metal, but something intentional, everything would change. For now, we simply keep watching. Subscribe. You won't want to miss what comes next.